Hi everyone, for this question, the curve C has an equation y equals to fx. Given that fx is this, find the limit at appropriate points, obtain the horizontal and vertical asymptote. So first we find out what's your vertical asymptote, second we find what's your horizontal asymptote. Before we get it to the vertical asymptote, firstly we need to find what is your domain. Domain will be looking on your function, what is the characteristic you have here? It is a rational function. So for sure, denominator cannot equal to 0. So x cannot equal to 1. X cannot equals to not equals to 5. Therefore, our domain will start from negative infinity until 1, then continue 1 until 5, continue 5 until infinity. So that is the part, this is the interval that we will have our graph. So that is why that is the domain. So when you want to find the vertical asymptote, your function is undefined at the appropriate point. So what is your appropriate point here? It will be x equals to 1 and x equals to 5. So where's the point that you want to find the limit for vertical asymptote? Where the point for your graph doesn't exist, where your function does not define. Alright, so x equals to 1 and x equals to 5. Therefore, we are going to calculate vertical asymptote using limit approaches a point, one from the left and one from the right. Then another point here will be x equals to 5, so x approaches 5 from the left and limit x approaches 5 from the right. Alright, so from domain here, actually you will know that your interval here, negative infinity until 1, 1 until 5, 5 until infinity, that will be your domain, that will be your graph. So we want to see when x approaches 1 from the left, 1 from the right, 2, 5 from the left and 5 from the right, what happened to your graph on the point which is undefined for your function. Your function undefined at x equals to 1 and x equals to 5. So we evaluate this. We substitute 1 inside, so 1 squared over 0. So we didn't calculate the whole thing because we know denominator 1 is undefined. For sure, you press your calculator, you will get max error if you calculate the whole thing. So we can only calculate it, numerator and denominator separately. So 1 over 0, we know this is infinity. This one also same, 1 over 0 is infinity. This one 5 square, so 25 over 0 infinity, and this is also 25 over 0 also infinity. Our infinity value, it will be positive or negative, then we will depends on what kind of value that you want to test here. So we can test our value when your x approaches 1 from the left, we will test on the value near to 1 from the left, which is 0.999. So from the right, we will calculate on the x, which is 1.001. You definitely cannot calculate x equals to 1 because it is the value that make your function undefined. You cannot calculate. You will get definitely mad error. So we just can use limit, calculate the value near to it. So for x approaches 5 from the left, we will calculate, we will test here. Later on, we will test here 4.99999. And when x approaches 5 from the right, we test on 5.0001. Okay, so how we know this is positive infinity or negative infinity? We just put it in to our calculator here. Our function here is alpha x square divided by, in the bracket here, alpha x minus 1 then alpha x minus 5, then we calculate. So what's the value that I can calculate? Not 1, because not 1 will be undefined. I will calculate the value near to it. Near to it, getting near to 1 from the left, which is 0.9999, getting near to it, alright? As near as you can. Approaches it as close as you can. So you can see you get a very big value, so positive infinity. Positive big value in positive, so positive infinity. Then calculate from the right, we'll be testing on 1.0001. So we get negative infinity, a big value in negative, so negative infinity. Then calculate 5 from the left, which is the value 4.99999. So we get this one negative infinity, and this one calculate 5 from the right, which is 5.00001. So very big value, positive. So after we calculate that, when we get our function getting infinity, negative infinity, from here we can conclude that x equals to 1 that we find and x equals to 5, there are vertical asymptotes. Okay, now we continue to horizontal asymptote. In calculate horizontal asymptote, our concept is finding limit x approaches negative infinity for your function. So function here I expand x squared, negative 5x, negative x, negative 6x plus 5. We were going to find the limit x approaches positive infinity and negative infinity. So both of these we can calculate because of we can see our x here will approaches negative infinity. Our x here also will approaches positive infinity. So this limit to infinity we suppose can be calculated. When we substitute infinity, evaluate this limit at infinity, we get infinity over infinity, which is IDF. So what can we do is we simplify, we divide with the highest power from denominator, which is x squared. So when we divide by x squared, we get 1, denominator 1, 6 over x plus 5 over x squared, and we evaluate the limits once again. 6 over infinity is 0. This one 5 over infinity, which is 0. So it is 1. Meanwhile, for this x approaches positive infinity, same case also is infinity over infinity. We need to divide by x squared. So I simplify it straight away. X squared over x squared, x squared over x squared, 6 over x squared, then 5 over x squared. Substitute the infinity, and we get 1. So coincident, we get both answers, they are same. Write your horizontal asymptote conclusion. Not just 1, you have to write out y equals to 1 is horizontal asymptotes. Alright, so after calculate these two, now I want to proceed finding, add on the question, finding the graph, drawing the graph. Alright, so I will draw out the graph. All the asymptote that we find here, we can draw out the graph already. X-axis, and then y-axis. The first two asymptotes that we can find, x equals to 1, x equals to 5. So asymptote, draw it in dotted line, 1, 2, 3, 4, 5. So at here, estimate. Then horizontal asymptote also you need to label. Y equals to 1. So make it longer for this x-axis. origin we label. Alright, so we start without our graph here. When x approaches -1, our function go to positive infinity. When x approaches 1 from the left hand side, the function go to positive infinity means the function going up. Second calculation here, x approaches 1 from the right. Function answer is -infinity. 1 from the right. Function is -infinity means your function is approximate downward here. Going downward, going as negative as it can. Then x, reading x here, x on 5 on the left. Function going downward. So it will be at here. Then some more, limit x approaches 5 from the right. On the right will be this side. Function is going positive infinity. Function going positive infinity means function going up. And we read for horizontal asymptote. As your x getting negative infinity means as your x getting as left as it can, go to the left here. Negative infinity, go to the left here. So your graph is approaches 1. Okay, so your graph one part is here. So it will be approaches 1. Will we have intersect? So it seems like you want to approximate x to negative infinity, pergi sekiri yang boleh, function menghampiri y. So graph menghampiri y1. So look like it will going to have intersect. So we find out. We calculate y intersect when x equals to 0. What is your coordinate? We substitute here. We substitute into our function here, x0. So 0 over 0 minus 0 plus 5, we get 0. So our intersection on 0 over 0, this is the intercept that we need to pass to. How will it be? Okay, so graph. Pergi sekiri yang boleh menghampiri 1. So it need to touch. So it need to touch first. We touch. Alright, so I need to stop here. I give you another video because it's hanging now.